Welcome to the Ready Academy. Tools for teaching, tools for learning, tools for life. In this video book, we cover simple machines. This content was produced with AI assistance and reviewed by a human instructor. We'll continue with the wheel and axle. Geometry and mechanical advantage. A doorknob hides a machine inside your door. The wide knob is gripped by your fingers. A narrow spindle passes through the door and turns the latch mechanism. Try turning a stiff latch by gripping the spindle alone. Nearly impossible. Now turn the same latch with the knob. Effortless. The question this section resolves: why does the larger wheel multiply force, and by exactly how much? A wheel and axle is two coaxial cylinders of different radii rigidly joined so that they rotate together as a single unit. Apply force tangentially to the rim of the larger wheel, radius R, and each full revolution sweeps the point of effort through a circle of circumference 2 pi r. The axle, radius r, turns through the same angle, so its surface travels only 2 pi r per revolution, a much shorter arc. Work conservation, equation 2.2, requires effort force times effort distance to equal load force times load distance. Substituting the two arc lengths for the distances, the 2 pi cancels and the force ratio reduces to a clean ratio of radii. Equation 4.1. The ideal mechanical advantage of a wheel and axle equals R divided by r. The wheel radius divided by the axle radius. Make the wheel much larger than the axle, and the force multiplication can be 5, 10, or 20 to 1. The IMA depends on geometry alone. Measure the two radii with a ruler, and you know the force multiplication without a single force measurement. Think of the wheel and axle as a continuously rotating lever. The central axis is the fulcrum, the wheel radius is the effort arm, and the axle radius is the load arm. Animation 4.1. The wheel and axle rotate through the same angle. They are one rigid body. A dot on the rim and a dot on the axle surface trace their arcs simultaneously. The rim dot sweeps a long arc. The axle dot sweeps a short arc. Arc length counters show the ratio converging to R divided by r, the same ratio as the force multiplication. Figure 4.1. A wheel and axle drawn as a screwdriver. The handle is labeled with a radius of r and has a rotation arrow of 2 pi r, while the shaft is labeled with a radius of r and a rotation of 2 pi r. The rotation arrow that circles the handle sweeps a much longer arc than the rotation arrow that circles the shaft. 2 pi r compared with 2 pi r, visually showing why turning the wide handle multiplies the force delivered at the narrow shaft. When the arrangement is reversed, effort on the axle, load on the wheel, the IMA drops below 1, and the machine trades force away for a larger output arc and greater speed. Ship's wheel. A ship's wheel has a 40 cm rim radius and a steering shaft of 4 cm radius. The rudder linkage requires 600 newtons of tangential resistance at the shaft surface. What tangential force must the helmsman pull on the rim, assuming ideal conditions? Step 1. Find the IMA. Apply equation 4.1 and divide the rim radius by the shaft radius. IMA equals r over r. 40 divided by 4.0 equals 10. An IMA of 10 means the helmsman's hands travel 10 times the arc of the shaft surface per revolution, which translates to a 10-fold force multiplication. Step 2. Find the effort force. Divide the resistance force by the IMA. Fe equals Fr divided by IMA. 600 divided by 10 equals 60 newtons. 60 newtons, about the weight of a small bag of groceries, overcomes 600 newtons of rudder resistance. IMA equals 10. The helmsman applies 60 newtons at the rim to overcome 600 newtons at the shaft. Screwdriver. A screwdriver has a handle 36 mm in diameter and a tip 6 mm in diameter. A user applies 8 newtons tangentially to the handle. What tangential force does the tip apply to the screw head? Step 1. Convert diameters to radii. Each radius is half the corresponding diameter. Capital R equals 36 divided by 2 equals 18 millimeters. Lowercase r equals 6 divided by 2 equals 3 millimeters. Step 2. Find the IMA. Divide the handle radius by the tip radius. IMA equals 18 divided by 3 equals 6. The fat handle is the wheel. The narrow tip is the axle. The screwdriver is a wheel and axle standing upright. Step 3. Find the tip force. Multiply the input force by the IMA. Fr equals IMA times Fe. 6 times 8 equals 48 newtons. Each grip of the handle sweeps 6 times the arc of the tip, so each newton of grip force becomes 6 newtons of screw-driving force. IMA equals 6. An 8 newton grip on the handle delivers 48 newtons of tangential force at the screwdriver tip. Windlass. A windlass used to draw water from a well has a crank handle 50 centimeters long and a winding drum of radius 5 centimeters. A full bucket weighs 200 newtons. What force must be applied at the tip of the crank handle, ideally? Pause the video now and give it a try. Steering column torque. A steering wheel of radius 18 centimeters turns a steering column of radius 1.5 centimeters. The steering gear requires 90 newton meters of torque at the column to turn the road wheels. What tangential force must the driver apply at the rim? Pause the video now and work it through. A faucet's wide handle turns a narrow valve stem inside the pipe to open or close the flow. Is this a wheel and axle being used as a force multiplier or as a distance and speed multiplier? Why is that the right design choice for a faucet? That wraps up the wheel and axle. Next up, Section 5, the pulley. If you found this helpful, like and subscribe and support the channel.